Good morning everyone. I am Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. And the last video series we are seeing about microprocessor and microcontrollers. I discussed about 8085, 8086 architecture addressing modes instruction sets. And in the last class I have explained about the parallel communication interface. And now we are going to see about the serial communication interface, that is UART 8251, Universal Asynchronous Receiver and Transmitter. It consists of various basic modes of data transmission, that is simplex, duplex and the half duplex, where simplex is nothing but it transfers the data in only one direction. That is, data is transmitted only in one direction over a single communication channel. Example, the processor, that is in CRT display, we are giving input, the output is displaying in the other side. This is the example for the simplex mode. Duplex is nothing but the data is transmitted in both directions simultaneously. That is, we can take example as our mobile phone. If we talk here, in the other side the receiver is answering, the sender is speaking here and the receiver is answering here. This is the best example for duplex mode. And next one is half duplex mode. In this mode, the data takes place in either any of the direction, that is, time data may be transmitted only in one direction, where the computer may able to transfer the data in the other direction. Then comes the pin diagram of 80 to 51. It also consists of 40 pin as like that of a parallel communication interface. 40 pin from pin 1 to 40. Here pin 1 and pin 2, that is X1 and X2. This is nothing but a clock frequency oscillators, that is clock signals. X1 and X2 are the clock signals. Next one is reset. SOD, SID is nothing but serial output data, serial input data. Trap. Here it is used to trap the data if it is sent wrongly. Here trap is used to function and it is used for trapping the data, that is trap signal is used here. Next, pin 7, 8, 9. These three pins are, that is trap RST 5.5 to 7.5, INT or INTA. These are interrupts. This is used if the data is transferring from one signal, one place to another place. If there is any noise or if it is anything is about to intermittent, this interrupts will be enabled. These are the various interrupt enables. Next one is address AD0 to AD7, and VSS is nothing but a power supply, VCS is nothing but a ground, hold HLDA, clock out pin is here. Next, reset in. Ready is for ready signal, and the address bus here from A8 to A15. Data bus is 8 bit, here address bus is 16 bit. That is was mentioned here. Address bus, it carries the most significant 8-bit data of memory and IO address. Next one is data bus, that is AD7 to AD0. Then the control and the status signals. There are three control signals and the three status signals. The three control signals are RD, WR and ALE. RD is nothing but read, write, and the AL is nothing but address latch enable. Here a read signal, which is used to read the data from the memory. Write is nothing but it is written the data into the memory, and AL is nothing but it is mainly used for generating them new operation which is being started with a microprocessor. On the clock signals here, I have told in the first two pin itself X1, X2, and X1, X2 are clock inputs, where clock out is the third pin. X1 and X2 are used as here internal clock generator. Clock out is the signal which is used as the system clock for devices connected with the microprocessor. Then there are three status signals, that is input, output or memory, S0 and S1. This signal is used to differentiate between the input and the memory operations. S1 and S2 are used to which is mainly used to identify which type of operation it is used. Next, I said VSS and VCC are two power supply signals here used. Interrupts and the externally initiated signals. That is what here for interrupts INTA, reset in, reset out, ready, hold, HLDA. These are mainly used for interrupt signals and serial IO signals. There are two serial signals, that is serial input data and output data, where output data SOD is set a reset and it is specified by the SIM instruction, that is single instruction module. Next, SID, that is serial input data line. Here the data is loaded to the accumulator whenever a RAM instruction is executed, that is RIM, read instruction machines. Next is the block diagram of 8251. It consists of data bus from D0 to D7 and address bus from A0 to A15. That is what here first block is data bus buffer. Next one is read or write control logic. Next one is modem control. Next, serial communication transfer is mainly for transmitter and receiver, which uses these operations. So transmit buffer, transmit control, receive buffer and receive control signals are blocks are used here. Here in this data bus buffer, the data bus buffer is mainly used to give the data to the internal bus. Then from read or write control logic, here it mainly controls the operation of the peripheral, which depends upon the operations initiated by the CPU, whether the address on the internal bus is control bus or data bus. Next one is modem control unit. It mainly handles the modem handshake signals to coordinate the communication between the modem and the USART. That is modem and the USART. Handshake signals is nothing but if you are sending data from CPU to the printer, whether the printer is ready for accepting the signal or not is being identified by the handshake signals. Next one is transmit control unit. Here the transmit control unit is mainly used to control the input frequency, and it also address to transmitter signals, that is TX RDY and TX EMT. RDY is nothing but transmitter ready and the transmitter is empty, is nothing is about TX MT. Next one is next is transmit buffer. It is a serial to parallel converter that receives a parallel byte for conversion into a serial signal. Next, as like that of transmitter block, receiver block also consists of a buffer and a transmitter receiver control and the receiver buffer, where receiver control is mainly used to receive the frequency as controlled by the input frequency. This is also being controlled by the handshaking signals, which is used by the CPU. Then it also consists of a receiver control. Here also it consists of two devices, that is RX ready and SYNDENT, which is nothing but synchronous detector, which is mainly used for synchronizing the various operations in the communication interface. Thank you.